So in the last video, we had a function f of x equals x squared minus 4x plus 7, and I drew a very bad rough sketch. I know the parabola is pointing upwards because I have a leading coefficient of 1. I know the y-intercept is 0, 7. This is clearly not to scale. Sorry about the bad picture, but this is, just a general idea of what it could look like. So we said in the last video, hey, if I want to find the slope or derivative or rate of change of the parabola when x equals 3, right? And I drew a little tangent line there, and I plug 3 into the formula for slope, right? We said that f prime of 3 was equal to 2, right? So we said, hey, when x is 3, it looks like the rate of change of the function or the slope at that point is 2, okay? Now, what's interesting is we could also use this derivative formula to find the vertex. So this is a little bit different than how you learned it in Algebra 1. In Algebra 2, you learned x equals negative b over 2a, and I can find the x value of the vertex that way and then plug in for y. But since we have a formula here, we can do it a different way. If I said to you, at what x value is the slope of the function 0, you could say, I'm not sure, but I know that happens at the vertex, because at the vertex, the slope is 0. So what you could do is use this formula, plug 0 in here, and so say 0 equals 2x minus 4, solve for x, and you could say, oh, well, when x is 2, then the slope is 0. So I know this x value is 2. Right? And then just like in Algebra 2, to get the y value of the vertex, you can plug 2 into the original function. So let's just do that quickly. So what's that going to be? 2 squared is 4, minus 8 plus 7, that gives me what, 3? So that means that the vertex, and you can check my math on that, hopefully I didn't mess that up, is 2, 3. So some interesting implications that come out of using the derivative. I hope that helped a little bit. In the notes, you'll notice that there's one more page where I do a cubic function. I find the derivative of the cubic function, and that allows me to actually find the local mins and the local maxes of the function, which in Algebra 2, you only could do by putting it in your calculator. So that'll be an interesting problem to do next.